Okay, so this tutorial is going to basically cover at first the conceptual framework for developing a 3D printable object in Rhino, and then go through material tolerances, sort of modeling of a geometry, and then we'll go through and set up how to run through how we can analyze the object once it's actually been built to make sure that it's in order so we can actually take it to one of the other 3D printing softwares. Okay, so I got loaded up in here a file that I actually have previously set up for 3D printing. This has actually been 3D printed already, so I'll probably post some pictures of this when this actually gets online. But the idea here is that you guys need to understand what you're going to be developing is a watertight object. So if you think about a water balloon, has a surface that is a surface on the interior. There's a very distinct edge that holds water, and then there's a very distinct outside that's the sort of rest of the universe. And if you pop that barrier, the balloon explodes and everything decompresses, and so nothing actually works. So it's a really good metaphor in that sense of understanding a very distinct inside and a very distinct outside. Okay, and so whenever you're actually modeling, you need to pay attention to that. Any geometry that you're going to take to 3D printing needs to have that distinct inside and distinct outside so that when you actually slice and dice or extrude, however you're printing, it knows where to place material or where to place adhesive so that that can actually be constructed properly. Okay, so I'm going to go ahead and let's take a look at, so we can just see this. Change the rendering color here. So this I modeled utilizing 3D scans of my body and then built some geometries around it. So this is a script that I wrote that plugged and played into the surface geometry that of a 3D body scan. What it started out with, though, is essentially a closed geometry. So if we come in here, we can create a closed geometry box here. And so this is essentially a 3D printable object at the start here. And you can start to model these things. Rhino is a surface modeler, so if I explode this and start taking away some of these geometries, you'll note that this is comprised of a series of infinitely thin planes that actually make up the geometry. So what we want to do is whenever we model a geometry that's going to be taken to a 3D printer, we want to make sure that that geometry is enclosed on all sides. It doesn't matter how many sides, it's just that it needs to be fully and completely enclosed and have a distinct inside and a distinct outside. So I'll rejoin that because we'll use some of this geometry later when we get into some of the analysis tools. And so what we want to look at when we're actually paying attention to and setting up the model is that we need to pay attention to what printer we're going to actually be utilizing and what are the tolerances for that. The Z-Core powder printers are very accurate, but they tend to make very, very fragile models. You don't really want to model anything for those particular printers beyond probably about 0.09 inches thick on that, and that's just at an absolute minimum. Otherwise, you won't be able to extract the model. And if you guys are going to be using an ABS plastic, a fused deposition modeler, you want to probably be in the range of at least a 1/16 of an inch, if not the same tolerance of 0.09 inches thick. And the reason for that is if you get too fine, when it slices and dices the layers on the FDM machines like a Dimension or Stratasys machine, what will happen is it'll not actually calculate that properly, and you'll get pieces as it goes through. Okay, and so you'll note that I've set this up here. I'm just moving along now to get this in here for the 3D printer. That this is not just one fused object. This is a collection of objects that are actually touching and occupying the same space. So when I actually go to take this to the 3D printer, it'll print as one continuous object, but what will end up happening is it's going to take all of these separate geometries and slice and dice them. This is really important. As you know, some of the Rhino tools here, we have some of these Boolean options here where we can start to fuse geometries together. This makes your models really clunky. It also will tear holes in your geometries. And suffice to say, you don't need to really get into that. You just need to know how to model the geometries and make them solid. And you can have an infinite number of those close geometries that identifies the part that you're actually going to be printing out. Okay, and that's true of all the softwares. All the softwares will take as many of those geometries as you want. In this case, if we select all these guys, we have 100 pieces of geometry in here, and so it'll understand and interpret all that perfectly when we actually get that taken out. Okay. All right. And so then the next thing I want to talk about here is actually getting this sent to a 3D printer. So say we've gone through and, like I said, I've already modeled this geometry. And so we know that these are, or hopefully that these are closed polysurfaces. So the first thing we can do to test that is we can do a select closed polysurface. You can see that right up here. Okay, and everything gets selected. So if we right click to repeat that command, we can do that. And so that's a good sign. That means that pretty much everything is good to go in there. We can also do a select open polymesh. And you'll note this got selected because this is, I punched a hole in this. And so we can see where some of our troubled areas are as we start to look at that. Okay, if once we have all of these tools set up and we know that this is a closed polysurface, we can now mesh this geometry. So by just typing the mesh command, we can go in here, and I'm just going to do something simple here. And it's going to calculate a mesh object, or a series of mesh objects out of those polysurfaces. So I'll click and drag this out. So we have our polysurfaces over here, and now we have our mesh objects. And you'll look at, the Rhino does a pretty nasty job of actually breaking this up. And doesn't really make this into a nice series of geometries that can be easily utilized. So if Rhino is not a mesh modeler either, so there's not much you can do with this once you get into it. And so really, if you end up tearing holes or something at the mesh command, which does occasionally happen, you're going to want to go back into your geometry and change your your mesh generation settings and things like that, or remodel some of your geometry. All right, so now we're going to run the same set of tests to make sure that this is still a 3D printable object here. So I'm going to do select close mesh. That's a good sign. The vast majority of our geometries are in here, and we'll try this again. We'll select an open mesh just to make sure. And it says no mesh objects were added, so that we're in really good shape. This is essentially ready to be exported to the 3D printer here. So what we're going to do before we get into that, before we actually get into the exporting, is we have a couple of things that I do want to cover with this that are also advantageous here in Rhino. If you guys are trying to figure out how much it's going to cost, you can do a volume estimate by just typing volume. This will give you the number of cubic millimeters. You can change your units, and you can put that into inches or whatever units you're trying to find out. That will give you a relatively good cost estimate for the powder printer. It's not so accurate for the ABS machines because you'll usually do a sparse interior for the larger parts, and obviously you're not going to be filling that up with a completely solid geometry. The second thing that you can do, if you do have some of these guys, getting into some of the geometries that you're going to discover as you go through and model it are going to have some problems. And so if we come in here, we can see if it'll let me do this. Great. Okay, so once we have these guys, if we have mesh objects that have problems here, what will happen is, I'm just going to go ahead and delete that. You're going to discover that, so this guy looks nice sometimes, and if we hit the invert button, here, some of your geometries, once you mesh them, are going to get confused, and so we're going to be able to look into and see some of these geometries. What this is doing is telling us that the front is actually the back, and the back is the front for all this. This translates and confuses the machine when it gets into analyzing the tool, and creates a big problem for us, because what ends up happening is it thinks the rest of the universe is outside in this little area, the rest of the universe is the interior of the model, and the exterior is only the small little bubble. And so what it'll do is it'll print a big old spool or a mess, or just it won't print, or it'll print fragments. It'll basically fail your print one way or another. And so what you want to do is, if you discover this, because you want to make sure you do a visual check of these guys, because if you still select closed meshes, this is still selectable, but its orientation is problematic here because everything is pointing in. And so you need to make sure that you have, make sure you do a visual check on these. Some of the softwares nowadays will actually pick that up and check that to make sure that nothing goes wrong, but or give you some dark blue or dark coloring when it actually imports the geometry. So you need to make sure you pay attention to that. So I flip this and hit enter. Now you can see this renders out as a nice solid object here. Okay, that's something you really want to pay attention to. The other thing is, if you're back here in your polysurfaces, I'm just going to go ahead and hide this for now. we're back here in our poly surfaces here. The one thing we can do here is if we don't know where the holes are, say we do a select open poly surface, and it gives us this opening, and we know that it's this geometry, so we can isolate the geometry easily, but we can't very easily get to the figure out which edge it is. If you come over here under the analysis tool here, there's a show edges or show. And so what you can come over here, this has already popped up. Typically it'll go be active on all edges if you've never used this tool before. If you select the naked edges, you can actually come in here, and then the really nice thing about that is you can zoom on the naked edges, so then it'll highlight that. And so as we come in here, I'll go ahead and so as we go in here and join these things together, we can add that object back in, and then it will highlight that again, and then we can hit zoom, and we can again continue to modify and fix our geometry until we get to that point where we actually at where we want. Oh, and, oh, and so we created this surface, and we can create all these edges and triangles, and we're good to go. And you'll note that up here it says these two surfaces or poly surfaces were joined into one closed poly surface. That means that we're in good shape. And so now we can take this and mesh it, pull that out, and we can now have a good object that we can take to the printer. All right, and then once you've done that, the last thing you need to do is you need to export this as a stereolithography file. So assuming we have everything scaled, we'll just hit export, drop down menu, and it is an STL. See if I can find it in here. There it is. All right, and so you can give this a name, and we're good to go. Okay.